the integral from minus infinity to infinity of e to j omega x fx of x dx. So when the only function that is a function of omega is only this part. So when we differentiate the characteristic function with respect to omega, we only differentiate this part, and differentiating this part with respect to omega, e to j omega x, gives you what is about j x, right?
Yes.
J omega x. Now differentiating n times, what do we get?
J to the power n and x to the power n.
Excellent. And because of that, we have basically, when we differentiate, we had here j to the power n, x to the power n, next to the e to j, the omega x. Now, when we set omega to 0, this goes to 0, to 1, sorry, and we are only left with this expression. However, what is inside the integral here? What do we know about this? This is by definition. Yeah.
The expectation of nth order, nth moment.
Exactly. It's basically the expectation of x to the power n. So this is basically this by definition. And hence, now looking at it backward, we can see that the expected value of so the x to the power n, which is the nth moment, equals, by dividing over j to the power n, it will be minus j to the power n, then multiplied by the derivative, the nth derivative of the characteristic function. Now the advantage of this is it is much easier to differentiate a function in times compared to integrating a complicated function. As you have seen in the exponential PDF, we were in order to find the second moment, we had to integrate by part twice. And imagine if you have more complicated functions. However, always differentiation is much easier than integration. Okay. Now, a related function, as I mentioned, the characteristic function is the Fourier transform of the PDF. If we take the Laplace transform of the PDF, then we end up with what we call MGF, moment generating function. Okay, it's very related to the characteristic function, except that we eliminate the j. So here we are mx of v equals expected value of e to vx. So there's no j, there's no complex exponential. Okay, so basically this is the kind of Laplace transform, and if we look at it, it will be basically the Laplace transform of the PDF. And the PDF is the inverse Laplace transform. It's very similar concept. Now, differentiating mx of v, which is the Laplace transform of the PDF, n times, we end up with also similar, if we differentiate with respect to omega, e to vx, what do we get? Shabab?
X e to the power vx.
Excellent. So if we differentiate n times
xn,
x
to the power n.
Exactly. Thank you. And this is what we get here, x to the power n. And now when we set v to 0, this goes to 1. And you end up with this. The good thing about the moment generating function, you will eliminate the j and the need to divide by j and minus j and so on. And this, by definition, is the expected value of x to the power n. Okay. Hence, the expected the nth moment equals the nth derivative of the Laplace transform of the PDF, or the MGF, the moment generating function of the random variable, with v set to 0. Okay. It's very similar to characteristic function. However, in some books, you will find that it's defined as moment generating function. In some others, you will find the characteristic function. In other books, you will find both of them. Both of them, as I mentioned, they have no physical meaning. However, they are used to mathematically simplify many problems related to random variables. أي سؤال يا شباب about how to generate the moments from the we'll take an example in a minute. However, any question about how to find the characteristic function first and how to find the nth moment? Fine, let's take the exponential function as an example, the exponential PDF, sorry, exponential distribution. So the exponential distribution is given by this PDF, if you remember. It starts from A and then decays. This is the way we have studied it before. Okay? Now, if we take the characteristic function of the exponential distribution, which is expected value of e to j omega x. So basically, you take the PDF, you integrate it from A, because it starts at A. Before A, it's 0. Okay? And then you take the PDF, which is 1 over B. You take whatever, anything that is not related to x outside. This is outside, not related to x. And anything related to x, you put it together. So basically what we did here is we group this exponential with this exponential. Okay? واضحة
Doctor,
شباب؟
can you repeat please?
طيب ال characteristic function of x, which is expected value of e to j omega x, right?
Right.
Which is by definition, it's the infinite, from minus infinity to infinity of e to j omega x fx of x dx, right? Now we know that the PDF starts from A, so it's A to infinity. Now we write the PDF. What is the PDF? So 1 over B e to, so the e2 minus, let me just do this, e2 minus x over b, x minus a over b, right? And then e to j omega x dx, right?
Right.
So now we take anything that is not dependent on x outside. So we take this minus minus, we take it outside. So we get here e to a divided by b. And we collect anything that is related to x together. This is minus x, and this is positive j omega x. So we put them together, we get this. تمام؟
تمام.
Okay, واضحة يا شباب؟ So now, integrating an exponential is simply get you basically this. Whatever next to the x in the exponential, you have to divide by it. So basically, it's the same exponential, e to minus 1 over b minus j, whatever inside the exponent, you divide by it here. And you integrate from a to infinity. Now, when we integrate to infinity, when we substitute to infinity, we get what?
0.
0. So it will be 0 minus, because we have a negative here. So it will be 0 minus minus, which is positive. And then we get whatever inside, basically when we substitute for x as b. So here will be a instead of x. Okay. Now simplifying and putting things together, you get e to j omega a divided by 1 minus j omega a. اوكي هذا هو الكاركترستيك فانكشن.
اوكي كل شيء واضح.
اي سؤال يا شباب؟ طيب الان in order to find the first moment, let's say, simply we differentiate the characteristic function once only, because we want to have the expected value of x to the power 1. So differentiating once, you get basically this expression. Simply the derivative of a function with respect to omega is the derivative of the numerator multiplied by the denominator plus the derivative of the denominator multiplied by the numerator divided by the denominator square. Okay, and we get this function. Now if we replace omega with 0, we get anything that is omega we get it as either 0 or 1. Okay, this is 1 and this is 0. And we get basically a plus b. And we know before, when we integrated by part, that this is basically the average of the exponential. Now, if you want to do it again, expected value of x squared, you need to differentiate this function twice again, and so on. However, differentiating twice is different. It's much easier in general than integrating a complex function. Any questions, شباب؟ كل شيء واضح؟ طيب, now if we look at it from the moment generating function MGF, which is the Laplace transform, we repeat the same exercise. So we find mx of v, which is the integral, which is basically by definition expected value of e to vx. So basically, next to the PDF, you write vx, expected value to vx, and this is the PDF. Again, differentiating, you end up with this function. This is basically the MGF of the PDF, of the exponential random variable. Now, in order to find the first moment, simply you differentiate this and set it v to 0. This same concept, you get a plus b. طيب. Any questions, شباب?
Doctor, we could use any one of them to find the first momentum.
Yeah, any one of them, it will give you the same answer. Unless I specify in the exam, in the question. However, in general, you can use any of them. أي سؤال؟ طيب, let's have a practice question. I want you to find, if I have A to B uniform random variable, okay, B minus A, I want you to find the average. I want you to find the characteristic function. يلا شباب. Find the characteristic function of a uniform distribution. You have 2 minutes. And send me over the private chat. شباب اللي كاتب you don't know, I gave you 2 minutes. Try to do it, please. We are not doing anything difficult here. Characteristic function is the Fourier transform of the PDF. This is a 207 or even calculus 101. So it's nothing that you don't know. It's very simple. So please exert the effort and work it out. شباب اللي I'm not sure, I don't know, I will not accept these answers. I will not accept these answers.
Doctor.
This is not a quiz. Like, you need to exert the effort. You need to exert the effort. You need to do something. The easiest is to stay on your couch sleeping and just type, I don't know. This is not the way we do it at KFUBM.
Doctor.
Further.
I tried to send you a message, but I don't know, but it refused to. I got your name and I want to open a private chat with you.
Okay.
But it refused. I will go outside and from the chat. Just a minute.
طيب no problem. It's okay. Take your time. طيب يا شباب كويك يلا خليكم. طيب يا شباب رابط اب. رابط اب. شباب اللي ما جاوبوا. طيب so what do we do in order to find this? As we mentioned, this is the expected value of e to j omega x. Right? Now, in order to find this, simply we write the expectation operator that we know. However, whatever inside comes next to the PDF. This is by definition is the expectation operator. Whatever inside comes next to the PDF. Now, what is the PDF? What is the range of the PDF?
From A to B.
From A to B. And what is the value of the PDF?
1 over B
1
minus A.
over B minus A.
Yes. dx. So basically we have what? We have, this is a constant. We have only an exponential. So what is the integral of the exponential? Whatever constant comes out, what is the integral of the exponential, Islam?
1 over j omega.
Yes. Yes. J omega. And this is from A to B.
To B.
Right? So it's simple. 1 over B minus A multiplied by E to J omega B minus E to J omega A.
Multiplied by 1 over J omega.
Yes, 1 over J omega. Where do I write this? J omega. Okay. Thank you. طيب sir, is it difficult? طيب now.
دكتور.
تفضل.
We don't use Euler identity to continue here.
We don't use what?
Euler identity. Identity.
Boiler identity?
Yes, to go more.
Yeah, it's okay. It's okay. You don't need to do so. So this is now the characteristic function. Now, if we want to find the first moment in this case, in this particular case, you will not be able to find it, because if you differentiate this, you will get j omega in the denominator. And if you set omega to 0, you will have an existence problem. So in this case, this will not be a valid approach to find the moments for the uniform. But in general, it's a valid approach. Not because it's wrong, because it doesn't exist. There's an existence problem. When you differentiate this once, you will get, and set omega to 0, you will have 0 in the denominator, which will have a problem in the existence. Okay? طيب شباب أي سؤال about the moment generating functions, about the characteristic function? طبعا as you can see يعني خلينا نقول from the EE315 point of view, this particular section is all about finding the Fourier transform of a PDF. The rest is simple math. And there's no concept to learn. There's no physical meaning, as I mentioned. It's a mathematical tool to simplify calculations for random variables. This is a self-study. I will just leave it for you. I will not put time on it. So it's an extra material, which is called the Chernoff bound. Very similar to the concept of the Markov inequality and the Chebyshev inequality, but this will not be covered in the EE315. So it's your own reading. Now we come to the last section of chapter 3, which is the transformation of random variables. As I mentioned before, in many cases, you need to process the random variable. For example, your signal is a voltage, and you are interested in the power of the signal. So in this case, if your signal X is your voltage, then your power will be X squared, assuming that the resistance is 1. Okay, so this is a function. This is T of X. In other cases, you have T of X equal linear transformation, AX plus 1, plus B. And this is typical, where basically you amplify and you add a bias. This is typical in electrical engineering. So, and there are many other transformations. For example, the square law detector method, X square, the absolute value of X. This is another T of X. And you can think about many others. The modulator, cosine omega X, assuming that X is the information. And this is in FM, for example. Right? So T of X, which is the transformation function, can take many different values. However, we will classify the way we look at it into continuous, monotonically increasing or decreasing. This is the first case that we'll tackle today. Next time, we'll talk about continuous, however, non-monotonic, when you have basically increasing and decreasing, goes up and down. So the function goes up and down like this. In here, the function either goes up or goes down. It's either increases or decreases. And the last one, when you have X discrete and the transformation is continuous. So what we try to do here is the following. The objective of this section is the following. Given a certain transformation T of X, and given the PDF or CDF of X, what is the PDF or CDF of Y? واضحة شباب? We want the PDF CDF of Y, which is the transformation of X. This is what we are after. واضح شباب ايش حنسوي هنا؟ طيب, so let's go with the first case. When you have X is continuous random variable and the function is either monotonically increasing or decreasing. Monotonically increasing function, a function that goes up, like here. So as X increases, Y increases. And the mathematical notation is for x2 larger than x1, T of x2 is larger than T of x1. Monotonically decreasing is the opposite, is this figure. Whereas X increases, Y decreases. So for x2 larger than x1, the function of x2, T of x2 is smaller than x1. Now, given a function that is increasing or decreasing, so Y equals T of X. Given the PDF of X or the CDF of X, we are interested in finding the PDF or CDF of Y. This is what we want to do. And this is, as I mentioned, has many applications, and you need to master this very well. So this is what we are after here. Let's see how to do it. Let's first start with monotonically increasing function, t of x. So we are looking at a function that looks like this. It increases with x. As x increases, y increases. Now we start with as I mentioned we always start by the definition. F y of y0 at specific y0. What is this equal to? By definition, the CDF of y at y0 equals the probability that y is less than or equal a number y0. Right? صح يا شباب؟
Yes.
طيب. Now, if this is y0, and this is the function, then the corresponding to it is x0. So this is y0. Just let me enlarge it. The corresponding in the x-axis is x0. So the range that covers the probability that the range that is y is less than y0 is the same in the x-axis as x is less than x0. Right? This is the same equivalent range, I would say. Which gives you, by definition, this is equal to the PDF of x, sorry, the CDF of x evaluated at x0. Okay? واضح شباب؟
Yes, clear.
So now, the probability or the CDF of y at y0 is nothing but the integral from minus infinity to y0 of the PDF of y, which is equal to the right-hand side, which is the CDF of x at x0. CDF of x at x0 is the integral from minus infinity up to x0, which is this is equal to x0, right, of the PDF of x. So we integrate the PDF of x from minus infinity to x0. But what is x0? y0 is t of x0, right? So
Right, doctor.
x0 is t inverse of
T
y0.
inverse of y0.
Excellent. تمام. So we integrate the PDF of x from minus infinity up to x0, which is t inverse of y0. So now if we are interested in finding the PDF of y at y0, what do? We differentiate this with respect to y0, right? So basically this gives you fx. We differentiate basically, this is, let me write it just. This is equal to derivative with respect to y0 of fy of y0, by definition, right? Okay? Now, if we differentiate this, we get fy of y0, which is what? Fx evaluated at, now if we differentiate this function, the right function, it is fx of evaluated at t minus t inverse of y0 multiplied by the derivative of t inverse at y0 with respect to y0. تمام? So basically, what is this? Fy, so this is at y0, at a specific y0, at a specific number. What about if we just leave it open for any y? What will this give you? Fy of y equals fx of t inverse of y, يعني evaluated at t inverse of y.
Which is x.
Yeah, exactly. It's x. However, we want everything at y, so because of that, we just remove x and replace y with anything related to y. Multiplied by the inverse derivative of y, of x with respect to y, or difference, يعني basically this is هذه هي نفسها هذه dx dy. Okay? or we can write it as fx of x divided by dy dx. Or we can write it as fx at t inverse. خليني بس امسح شوية اشياء. لو تقفل الميكروفون لو سمحت. Okay. Either the derivative of the inverse, or you can just divide by the derivative of t y with respect to y. dy. Okay. واضح شباب؟
واضح.
Now, if we have decreasing function, it's the same concept, except that the range will be different. So if decreasing function, if we start with the same concept, fy of y 0, which is a probability that y is less than or equal to y0. Y is less than or equal to y0. If this is y0, then this is the range, right? However, this corresponds to what? The function is decreasing. So this corresponds to if this is x0, this corresponds to the range that x is larger than or equal x0. Right? واضح يا شباب؟ The opposite الآن لأنه هذا decreases. So as we go y less than y0, as we go down, we are going up in x. X is larger than or x or equal x0. And this probability is equal to, by definition, 1 minus fx of x0. So going with the same concept of derivation that we did before, fy of y will be minus fx dx dy. So there's a minus sign here. Okay? So now, putting things together, both of them, انت شوف لما يكون عندك positive, you have no minus. When you have a negative or decreasing, you have minus. So putting them together, fy of y will be fx of x dx dy absolute value, or fx of x divided by dy dx absolute value. واضحة يا شباب؟
Doctor, isn't the same as the previous one?
نفسها بس الفرق انه صار في absolute value هنا because of the negative. لما يكون عندك positive it's positive. لما يكون عندك negative function decreasing, you have a negative sign, and because of that you have absolute value. You put absolute value for the generic case. So the general case is the absolute value. واضحة؟
How could we know if it is decreasing or increasing then?
Yes, this is the general case. So this is for monotone, whether decreasing, increasing, or decreasing, ما تفرق. لكن لازم يكون واحد منهم، ما يكون multi value، ما يكون يطلع وينزل. This is not monotone. Monotone means what يا شباب؟ طالع مرة واحدة باتجاه واحد أو نازل باتجاه واحد. Monotonically increasing معناها يتم طالع. Monotonically decreasing معناها يتم نازل. ما يطلع وينزل مثل الكوساين. Okay? So this is monotonically increasing or decreasing. General case is this. This is the solution. Okay? Let's have an example. What do we have here? We have a Gaussian random variable. So a PDF that looks like this, with AX as the mean and sigma x squared. وتذكر الجاوسيان random variable كان كده شكل PDF. So this is Gaussian random variable. Okay. Now we define y, which is t of x. t of x as ax plus b, which is linear transformation. هذا نسميه linear transformation. Why is it linear? Because the function is linear. Amplification plus bias. We are interested in finding fy of y, which is the PDF. So the first thing we ask ourselves, is this t of x monotone or not? Monotonically increasing or decreasing or not? ايش رايكم؟
Yes, it is monotone. Depending on the value of A,
Yes,
it will increase or decrease.
exactly. So it's either something like this if A positive, or something like this if A negative. However, it either goes up or down. And because of that, we can find the PDF of y as the PDF of x at x equals t inverse of y. So what we put here at the end يا شباب ترى يمكن مو واضحة هنا. Here this needs to be evaluated at x equals t inverse of y. لأنه ما ينفع هنا y وهنا x. At the end I need everything in terms of what? y صح؟ fy of y is a function of y. So x has to be replaced by the t inverse of y. Similarly here, x equals t inverse of y. So now, knowing this, the PDF of y equals the PDF of x, the same PDF of x, with x replaced by t inverse of y. What is t inverse of y? كم كانت y equals ax plus b صح؟ هذه t of x. طب what is x from here؟ شباب what is t inverse of y؟ ايش رايكم؟ شباب معايا ولا لا؟ What is t inverse of y? What is x equal to from this equation?
y minus b over a.
y minus b over a. وهذا اللي سويناه هنا. And this is what we did here. It's fx evaluated at y minus b over a multiplied by the derivative هذه هي d x dy أو 1 over dy dx. ما تفرق. الآن y equal ax b. What is dy dx?
A.
It's a, right? And this is basically 1 over a. But we put absolute value because this is a general case for a positive, for a negative. It's a general case. واضحة يا شباب؟ So now, in order to find this, simply we take the PDF of x, we replace it by y minus b over a. هذه هي الx كانت هنا. We replace it by هذه. And a we divide by 1 over a absolute value, which is this one, the red one. تمام? Now, just opening up things, this stays as it is. However, if we just open up this, we can write it as y minus ax plus b all square divided by do 2a square sigma x square. So we can write this in terms of a new function that looks like this. So واضح ايش سوينا هنا في الاكسبوننت؟
multiply everything by a square.
Yes. طيب. So basically what we did, we can write this as 2 pi sigma y square e to minus y minus ay square divide by 2 sigma y square. ايش رايكم؟ هذه شكلها نفس الجاوسن ولا لا؟ ايش رايكم؟ Is it Gaussian PDF or not?
دكتور.
Yes, it is.
It is, right? However, what is the value of ay here? شباب
It is the transformation evaluated at AX.
yes, it's a
square
ax plus
بلس بي.
صح؟ هذه هي. شوف انتوا لاحظ اللي ايش سوينا احنا. انا ما سويت شيء ترى. What I did is I took this سميته ay. right? واضح؟ وهذا اللي صار هنا. يعني لو تلاحظ هي y minus هذا الشيء ax plus b سميته ay او حطيته ay. واضح شباب؟
but the ax a square.
لا ما في a square فوق. لسه ما جينا ل a square. سيجما y square equals what?
اوكي. a square
a square and
sigma
sigma
ax square sigma x square. right? تمام. So basically ايش ال conclusion from here? If we have a Gaussian random variable, then the linear transformation of a Gaussian random variable gives you another Gaussian random variable. The only difference is that the mean will be different. هذا المين الجديد, which is nothing but as if you are applying the transformation to the mean, and the variance will be multiplied by the amplification اللي هو a square. واضح؟ واضحة يا شباب الفكرة؟ So linear transformation of a Gaussian random variable gives you a Gaussian random variable. Any question? How do we do this? How to find the transformation? Let's have another example. A Gaussian random voltage x has a mean value of x bar equal ax equal 2. And the variance sigma x square equal 5. The voltage is applied to a square law full wave diode detector with a transfer function or characteristic as y equal 7x squared. Find the mean value of the output voltage. Okay? Find the mean value of the output voltage. تتذكروا احنا لما قلنا mean value ايش هي عبارة عن expected value of y. We have two ways to do it. Either by writing expected value of what is y equal to ايش بقى؟
7x squared.
7x squared, right? And try to find this using the PDF of x. Or try to find the PDF of y and then come up with the mean of y, which is easier. تكلمنا قبل كذا لو تتذكروا. If I don't need to find the PDF of y, why would I go through this hassle? I go directly from here. So what is this equal to? It's equal to 7 expected value of x squared, right? But what is expected value of x squared? هل عندنا معلومات عنها ولا لا؟
Variance.
لا. And variance is not expected value of x squared. So what is expected value of x squared?
integral.
Yeah. We can do integral and so on. However, you know, you have all the information. You don't need this. فكروا شوي.
Y over 7.
No. لما تتذكروا الفاريانس كيف جبناه؟
زيرو.
لا. الفاريانس يا شباب كيف حصلناه؟ expected value of x minus x bar square, right? And we opened it up and simplified. We ended up with expected value of x squared minus x bar squared. لو تتذكروا صح؟
صحيح.
So from here, what information do we have?
We have x bar.
We have x bar. What else?
We have sigma.
sigma x squared, and what we need is expected value of x squared. So what is expected value of x squared?
25 square equal
It-
7
sigma squared
sigma square
plus x.
plus x bar squared. Right? So it's 7 multiplied by كم?
25.
ليش 25؟
It's 5. Yes, 5.
5.
square.
هي sigma x
sigma
squared is 5. Plus كم؟
4.
4.
4 which is 2 square. طيب 4 زائد 5 9 9 في 7 كم يطلع معكم؟ يا شباب
63.
63.
ممتاز. هذه الآن which is easier this or finding the PDF of y and so on. طبعا حنيجي على كيف نجيب PDF of y when you have x squared but not yet. Next class إن شاء الله. طيب أي سؤال؟ So next time inshallah we'll continue with this example, the second one, and then we'll continue with the non-monotonic transformation. أي سؤال يا شباب؟ Time is up, I think. So you are free to leave if you have anything. If you want to ask anything, please